Welcome back. We've assembled all the pieces, the loss function that creates the error landscape, and the calculus that gives us a compass. Today, we put it all together with the algorithm that does the actual walking, gradient descent. Gradient descent is the master optimization algorithm that trains virtually all modern AI. It's the engine of learning. Its job is to take our loss function and systematically find the set of weights and biases that results in the absolute minimum loss. It's the process of the hiker actually walking down the mountain to find the bottom of the valley. Let's visualize the process one more time, because it is the most important concept in deep learning. Step 1. We start with a random model, which is like dropping our hiker on a random point on the loss landscape. Step 2. At that exact spot, we use calculus and backpropagation to calculate the gradient, our compass that points uphill. Step 3. We update all the weights in our model by taking one small step in the exact opposite, downhill direction. Then we repeat this loop millions of times. Now, a critical part of this process is deciding how big our steps should be. This is controlled by a setting called the learning rate. It's a small number that we choose. If the learning rate is too big, our hiker will take giant leaps and might jump right over the valley and end up on the other side. If it's too small, our hiker will take tiny, shuffling steps and it could take forever to reach the bottom. Choosing a good learning rate is a key skill. There are also different strategies for this walk. Batch, gradient descent looks at the entire dataset before taking one step. It's very accurate but incredibly slow. Stochastic, gradient descent looks at only one single example before taking a step. It's very fast but very noisy. The modern standard is mini-batch, gradient descent, the perfect compromise where we take a step after looking at a small batch of, say, 32 or 64 examples. We repeat this process of taking small, downhill steps over and over again. Each full pass through our entire training dataset is called an epoch. After many epochs, our model will eventually arrive at the bottom of a valley, a point where the slope is flat and the loss is at a minimum. At this point, the learning stops and we say the model has converged. And that is the engine of AI. Gradient descent is this beautiful, simple loop that allows a model to start off stupid and, by repeatedly checking its mistakes and taking a small step in the right direction, become an expert. In our next lesson, we will see exactly how this process works on one of the simplest and most fundamental models in all of machine learning, linear regression.